Alrighty, so this is my Make a Concentration Series of Solutions lab. As you guys can see here, I have my Kool-Aid or my solid. I thought it would be cool to use Kool-Aid since it's mostly characterized by sucrose contents. Hence, since it's sucrose, of its contents is what its contents are made of. I decided to calculate the molar mass of sucrose. This came out to be 342.154 grams per mole, as you can see here. I then proceeded into finding the total number of moles per packet. I used the mass given to me by the packet, the 3.9 grams, and divided it off by the molar mass of the sucrose that is mostly contained in the packet. This gave me 0.011 moles per packet. I then proceeded into calculating the total volume that I was going to use from my mother cup. This came out to be 0.265 liters as I converted the milliliters in my measuring cup into liters as I found it more convenient. I then poured the 0.60 the volume that I had in my measuring cup into the mother cup. Then carefully dumped all of the contents of my packet without leaving any residue into my mother cup. And then from there on, I decided to find the molarity of my first cup in order to calculate the molarities of my preceding baby cups. I found this to be 0.042 since I divided the total number of moles per packet that I just emptied and by the total number of volume that I used for my first cup, the mother cup. Then from here on, I proceeded into finding and making my set of other solutions. For my second solution, I decided to use 25 scoops of my first solution of my mother solution, pour them in, then use 0.15 liters measured from my handy dandy measuring cup, pouring it in, and then this gave me my second solution. As for my molarity of my second solution, I used 0.042 of my my first molarity times the total number of scoops, which I calculated to be 0.04 liters per scoop, as I made a proportion of tablespoons to the 50 milliliter line here, and this came out to be, as I mentioned, 0.004. I then multiplied this number by the total scoops in each one of my solutions, and for my first solution, this came out to be 0.1 liters withdrawn. And then for my second volume, I decided to use 0.15 liters. However, I had to account for the 0.10 liters I had just withdrawn from my mother solution, and then this came out to be 0.25 total for volume. I multiplied it out, then divided the volume to the other side, giving me a second molar mass of 0.0168, rounding it to 0.017, as only two significant figures were found. For my third cup, I decided to use 15 scoops of my second cup. Then I also used 0.25 liters measured out by my measuring cup again, poured it in, and got this solution. Then from here on, I decided to find the third molarity, which I used my second molarity times the total amount of scoops, which I multiplied by 0.04, giving me 0.06 since it was 15. And then adding these 0.06 into the 0.25 of volume, giving me 0.31 for my final volume of my third molarity. I then multiplied it out, divided 0.31, got a third molarity of 0.0033 when I rounded off the giant number given me by this equation. Then for my fourth cup, I decided to use 10 scoops of my third cup. Then I also used 0.175 liters of my measuring cup and poured it in and gave me that solution. For my fourth molarity, I multiplied my third molarity. To acquire my fourth molarity, I multiplied the third molarity by the total number of scoops and equal that to my final volume, accounting for the scoops, giving me 0.215 for volume. Multiplied it out, divided 0.215 to the other side, giving me 0.0006139534834, rounding it to 0.00461 and this was my fourth molarity. Then as for my fifth cup over here, I decided to use 5 scoops, poured in 5 scoops again with my with my teaspoon, and then I also decided to use a volume of 0.295. Added the 0.2 that I acquired from multiplying the 5 scoops by 0.004, and multiplied it out, divided, got a total molarity of 0.000044. And thank you.